Welcome to Suntech Engineering. By the end of this lecture, you'll learn how to organize codes in scripts, how to display, format and combine texts and numbers, and how to store formatted strings using examples.
Hello everyone, welcome back to our MATLAB for Beginners series, and this is lecture number 4. In today's session, we will dive deep into some very important MATLAB concepts and commands that every beginner should know. We will start from the very basic to advanced examples for better understanding. Most learners know how to display values, but only a few truly understand how to display data properly with precision and formatting control. Even experienced programmers sometimes face confusing errors while declaring variables, arrays, or using display functions incorrectly. So in this lecture, we will learn how to generate new scripts and write commands in scripts using examples, how to correctly declare and display variables and arrays, how to avoid display related errors, how to format numbers and text precisely using different methods. Let's start with the simplest one, display. On your MATLAB command window, just type display function. Welcome to MATLAB programming and press enter. This will simply display your message and move to the next line. It's quick and clean, but it does not allow you to format the output. If you observe, I didn't place a semicolon here. If I place a semicolon, it will display the same message. So using display function, the semicolon is not important. Now if I create a variable, let's type radius is equal to 5 semicolon and type the message display radius. It will give me the 5 value which is stored in radius. So MATLAB will print just the value of radius. But what if you want to display both text and variable together? Let's try this. Area is equal to pi into radius power 2 semicolon display, and right here a text message area is equal to comma and type the name of this variable area. It will give me an error. So too many input arguments. This argument is actually not correct. We have to place the brackets here, and then it will give us another type of error. It is not displaying the value of area. Because MATLAB cannot combine text and numbers directly. To fix this, we use num2string function, which converts a numeric value into a string before concatenation. Let's try again this and num2str using the same command, but just writing num2string, and it will give me the area as having the radius 5. So it consists of 2 integer numbers, and after decimal there are 4 decimal values. So that's perfect, but we can also control how many decimal places we want to display. For example, I extend the same command, and here I write %.2f and press enter. You see that after the decimal point the numbers are reduced to 2 because I placed here after the decimal point I placed 2. So this is plotting point. This limit the result to 2 decimal places. We will further discuss about use of %d, %f, %s, etc. in details using examples. But for your information, these are placeholders that can be replaced in a function or display with actual values. Let's move the discussion further by writing commands and scripts. But before starting about writing commands, you may think about what is a script. So a script in MATLAB is simply a set of MATLAB commands saved in a file with the .m extension that are executed line by line when you run it. In other words, a script is like writing commands in the command window, but saved together in one file so you can run the whole sequence anytime. So you can create a script in several ways. Using the toolbar. From the toolbar, click New Script in the Home tab. It will generate a new script file with the name untitled. So here you can type your commands. Anything that you write it here, it will be saved the script file. But first you have to save the document with a suitable name. Another way is you can type in the command window, edit. Let's give it a name, my script, and press enter. It asks me that there is no file in the directory. So do you want to create it? Yes, I want to create a new script file with the name myscript.m. So I don't want to save that one. Another way is to type Ctrl+N and quickly it will move to another new script file. Another way is move here. It will create another new script file. You can also use the live script option. MATLAB also support live scripts with the name .mlx files. It will be in .mlx files. If I save it, it will be saved in .mlx files. You see, which let you combine code, output, and formatted documents. You can type it anything here. For example, I'm writing anything. It will be saved in this live script option. They are great for teaching or creating reports, but for now we will focus on normal.m script files. You can run the script in different ways. By clicking here, run the script file, or type the script name without .m in the command window. Here, type my script, and even don't write .m extension. Just write my script and it will run. What is inside my script, it will run automatically. Or you can even write run my script.m. Here the extension will be important to write. It will again run it, but I haven't to write anything, that's why it's moving to another line. You can use the %sign to write commands in a script. MATLAB ignores anything after number sign on the same line. For example, I'm writing this is my first script program, MATLAB program. If I run this script, it will not read this line. Writing first example, like for example, I'm writing radius is equal to 4, and here I'm writing a command, it's radius. Okay, in another line I'm writing area is equal to pi into r square. What is this? I want to write in the command that is the formula of area. In another line I am writing circumference is equal to 2 pi r. I'm writing in the command that it's the circumference formula. Now I want to display the message using the brackets inside the parenthesis. Writing text area is equal to comma num to str area. In another line, I'm writing again the display message that display me the circumference of the circle num to str circumference. So if you run my script in MATLAB, it will display the area and the circumference of the circle. This area is given and circumference is given. It's calculated the area and circumference. You can also create a section title in scripts using $sign, which helps divide code into parts. For example, I want to write it here. Move the circumference to this section. It will actually create two different sections. I can even make it another section in this way. So in this line, in this section, in the first section, I'm just declaring a variable of radius, and in this second section, I'm finding the area. To find the area, it's a good way to write the commands in each section. To find circumference of a circle. So each section can be run separately. For example, I'm writing here CLC clear all, or I can write clear variables. It's a good way to write variables. And close all is not important as there are no figures to close the figures. So I'm writing these two lines as well, and save it. And now if I run the different sections at different time, for example, each section can be run separately in the MATLAB editor by pressing Ctrl plus Enter. If I enter Ctrl plus Enter, then if I see in the window, I will find that R is declared here. In the command window it's not showing, but R is moved here in the workspace. If I want to run this section, then my mouse should be in this section, otherwise it will not run this section. If my mouse is in this section, it will run only this section. So let's run the second section. For example, if I want to run this section, then it will find me the circumference. If I move my mouse in this section, then it will run me the second section, circumference and area. So in this way we can deal in scripts. This is your first MATLAB script. So we want to extend it further. When you run a script, all variables created in that script appear in the base workspace. You will find it here. The same workspace that the command window uses. It's the same workspace that it is using by the command window. If you type who, you will find which variables are placed in the workspace. So scripts share variables with the base workspace. This is convenient for short tasks but can cause confusion in large projects. Unlike functions, scripts cannot directly accept input arguments or return outputs. We will study about functions in more detail in next lectures. However, you can interact with users using input for user input. If you want to ask user to input a command, or display or fprint formatted printing function for displaying results. Remember, display is great for simple messages, but when you need formatted precision, we move to fprintf. That is another important command, another important function. Now let's move on to fprintf, one of the most useful display functions. Let's type another command here. I'm writing fprintf the area of the circle is equal to, or I'm writing is %.2f, and then type \n comma area. Click enter, but I want to remove this command here right now. Run the code. It will display me the message the area of the circle is 50.27, circumference is equal to 25.137. So it's giving me the message as well along the value. So this is replaced by the value of area %.2f. But if I use it in display, it will not remove %.2f. For example, I'm just giving you example, copying this in this area in the argument and try it whether it will run or not, or it will give me error. So you will find that the area of the circle is %.2f. It is giving me 2 value, but it is not replacing it with 0.25. So it is not a correct way to use .2f inside display. So but we can use it in fprintf. If I'm using the display function, for example, the display function and .2f. If I'm writing .2f, then again it will give me the value of area, but only the 2 decimal values. And if I use again this, there are 2 integer values before the decimal point. If I write, for example, if I write 1, it will display me the same message 50. I am writing it, I am giving it command that write only 1 integer value, but it will not accept it because there are actually in this number there are 2 integer values. If I write 4.2f, again it will not accept it. MATLAB will ignore these values. And if I write, for example, .f, it will give me only the integer value. It's the same like I'm giving it 0.0f, right? So if I write 0 or not, it will give me only the integer value. If I remove the dot, the point, then it will display the whole message. So it's not a correct way because it's a floating point value, so we have to write a decimal point and then how many values we need after the decimal point. For example, 4, then I'm writing 4 and it will give me the 4 values. So again move to the script file. So in this line fprintf, in this function line, .2f means display the floating point value up to 2 decimal places. \n simply moves the cursor to a new line after printing. If you remove \n, MATLAB won't jump to a new line. You can try it by yourself. Now let's print multiple variables together using the same values. For example, I am writing radius 5 and the same formula. The area of the circle is %.1f. In another argument, I'm writing the area is %.2f, comma radius, comma area. So here I want to, instead of area, I write here radius. Run the script file. It will give me the radius of the circle is 5. The area is the radius and the area is 78.54, and circumference is the same. So you can see how clean and professional that looks. You can remove this %n, then you will find it in more accurate way. You can see it's printed in one line. So input is another important command which can be used to ask user to enter value. For example, instead of a fixed value, I'm writing a command that will ask the user to enter the radius is equal to, and save it in R. Let's run this MATLAB script file. So it asks me that to enter the radius. Unless I enter the value, I will enter the value, press enter, then it will execute the commands after the input. You can also use other format specifiers. For example, we can use %d instead of %f. We can use %d for displaying integers or whole number values. Even we can write %e for scientific notation, %s for string format to display text string. For example, I'm writing a command here. %.3e \n. But before printing, I want to write a text here. Circle radius. And input the argument text here as well as the area. Write it here, the %s of the circle is in area. The %s of the circle has an area, %.3e text and area. Let's print this. It will again ask me to enter the radius, and you can see the message, the circle radius. You can see the %s. The %s is showing the text value. It is getting the text value, which is the circle radius of the circle. The circle radius, it should be removed. The circle radius has an area in scientific notation. So similarly, we can write some more commands here. Let's try with display and remove the input. There's a fixed value, and in the display I'm writing something like area of the circle is equal to %d \n, and instead of num2 str I'm writing round area. So let's run it and see whether it will generate this code or not. So the area is %d.n and it is not giving us the value. So it gives us the error because the display can only display text or numeric arrays. It does not interpret formatting specifiers like %d, %f or %n. It just prints the raw characters. So good way is to write fprintf, remove these brackets and run it. You can see it gives us the area and the circumference. So it's correct now. The argument inside display must be a single array or string. If I type it here like area is equal to, then it will give me an error because the brackets are missing. Round, I am writing num to str. First I have to convert it to str, then round the value. But it is not rounding it again because it's the incorrect way. The round should be not here, it should be here. Round area. First we have to round the area and then convert it to num to string. You can find it that it's now the value is now round to integer value or whole number. So fprintf is a formatted output function. It interprets formatting operators like %d, %f, %s, %e and replaces them with the corresponding argument values. If I write here %d, for example, I'm writing %t. So it places an integer value here in fprintf. And when we round the value, it actually provides the numeric value. Now move to another command, sprintf, that is very similar to fprintf, but instead of displaying the results, it stores the formatted text into a string variable. For example, I am typing a message here, text is equal to sprintf, the area of circle is equal to is %.2f and write area, and then write the display message or display text. Make it as a comment and it will not be run. So run the code and it gives me the area of circle is %.2f is replaced by the value of area. So it display actually not only the message or the text but also the variable value. This gives the same output, but now text holds that text as well. You can later combine it with other text or write it to a file. Here is another example. For example, I'm writing sprintf. I'm writing radius is equal to %.1f, comma area is %.2f, comma radius. Write it here, radius and area. Display a message here, but important thing is to write the brackets here as well. Results run the script file now and it give me the results is equal to radius, area of circle, and so it's a complete message now. So sprintf is very important. You have observed the difference between the fprintf and sprintf. So the big difference is fprintf can directly display on the screen, while sprintf stores the formatted message as text. The display function can also use to directly display arrays, vectors, and matrices, and that's one of the reasons it's widely used for quick visualization of data. For example, I'm writing another command here. Let's write a 1 2 3 4 and write display a. It actually prints each element separated by spaces. MATLAB actually prints automatically each element separated by spaces. Now let's try a column vector. The same, but write semicolon here between these values and display A. If you have a matrix, it works beautifully as well. For example, I'm writing 1, 2, 3 and 2, 3, 4, 3, 4, 5. Display matrix A is equal to display A. So display automatically arranges row and columns, but you can't control formatting such as decimal places or alignment. If you want to join text with numbers, you must convert the numbers into strings. For example, write a command display array A is equal to num to str matrix A. Dimension of array being concatenated are not consistent. So let's try another example. Let's try another vector 1, 2, 3, 4 and write the same message display display B. Array B is equal to 1, 2, 3, 4. If you have a matrix, it works beautifully as well. Now if we move to fprintf, it gives you complete control over how numbers appear, including decimal precision and layout. For example, let's clear the screen, clear variables. A is equal to 1, 2, 3, 4. fprintf %d, comma A. So you can see that it prints each element in the same row, but there is no space between them. Here %d is a format specifier for integers. \n moves the cursor to a new line. You can also control the number of decimal places. For example, try another example. 1.23, 4, 5.678, 9.156. fprintf, write the command here, %f, %.2f, comma b. So it's actually round the values, but the main issue using fprintf is it removes the spaces between these values. So it's one of the big drawback. To move the cursor to next line, we have to write fprintf and \n. For a matrix, you can use a small loop to display each row, but it's out of scope now. We will learn about loops in coming lessons. Since scripts run in the base workspace, variables are visible after execution. This can be helpful for quick experimentation, but in complex projects, this can override existing variables accidentally. Best practice is to always check variable names or use functions for isolated workspaces that will be studied in next lectures. Scripts are excellent for automation. For example, you can automate data loading, plotting, or report generation. For example, I create a new script file copy these. Write a variable x is equal to line linear space 0 comma 2 pi comma 100, y is equal to sin x, plot. I'm using now plot function x comma y. We will study about the plots in more detail in coming lesson, but for your information I'm just writing width comma 2. Now x label, write x label, x value of x, value of x, and y label sin of x. Title, write the title of the plot sine wave and write grid on. Running this script will generate, first I have to write save the file sine. Here I have to write the comma and then run the code. So you see it's automatically generated the plot. So it's very easy to write the commands in script. You can combine scripts with functions. A common MATLAB workflow is to use functions for computation and use scripts for coordination, for calling those functions, plotting results, etc. For example, I can write functions in different windows. Like for example, I'm writing here function A is equal to circle area, or here I save the file with sine wave, so I write here sine wave and put the argument R. Remove these values because it's not needed here now, and inside the function I'm writing some commands, pi into r square, and then if when the function ends, then I have to write the end function in here. It will end the function. So after end, I'm writing r value, then write the function name sine wave and put the r value here, and then print this value using this function fprintf. Area is equal to percent dot to f. After backslash I'm writing a. So I don't need these lines now. These lines should not be included in this function. So I'm writing another script file, save it with the name main circle. If I run this code, it will give me the area of the circle. So this combination keeps your code clean, modular, and easy to maintain. Large scripts can be divided into different sections, as we have divided these. So you can run one section at a time, which is great for testing. So always start script name with a letter. Never use an integer in the first letter of the script. Avoid using built-in MATLAB functions, MATLAB names like sum, max, plot, etc. Don't try to name it like data plot.m or plot.m. Group scripts, functions, and data files in a single project folder. Try to save it in a single folder, as I save it in a single folder. Always add comments and headers. Always include a short description at the top of each section. So scripts are your first step into MATLAB programming. They are simple, flexible, and great for learning. Once you become comfortable with scripts, you will find it easy to move toward functions which offer more control, reusability, and structure. So before jumping into complex functions, practice writing and running a few scripts daily. Load data, perform small calculations, plot graphs, or automate file handling. That's how you build a strong MATLAB foundation. So that's it for today's lecture. In this lecture, we explored the essential display functions, sprintf functions, fprintf functions, and learned how to control precision, formatting, and variable output in MATLAB scripts. In the next lecture, we will move toward different types of plots and functions. If you found this video helpful, don't forget to like, subscribe, and comment below your practice results. Let's keep building your MATLAB foundation one lecture at a time.
Thank you for watching the full video. Don't forget to subscribe to the channel and ask your queries in the comments below.